So let's have a bit of revision first about on the first session, and I'll talk few things on the first session, and then we'll move on to the next part, right? And basically, I gave you a file, and just I put that in the Skype chat, where you can find a file called basketball.csv. I think we used the same last week. However, like let's use the same for this week as well. So before you begin, and you're supposed to really get to know whether you are in the right kind of directory. So what you will do here, like getting to know your directory. Any answers? Maybe you can just come online and then tell me and whether you know the answer for this one. What will you do to get to know your directory? Any idea? Or it's like maybe in the chat box. Okay, then let me explain you. So in order to get into the directory, you are supposed to type in a command called get wd. And now let's execute with control enter. And for me, it shows me a kind of document, and I believe this will be the place where your R Studio is installed. Right? And then next, and you want to set your directory, you are supposed to say set wd, and you are supposed to go and locate your file in your system. And I have the file here, and I'm copying the path and putting it in. Okay. And what are the other things that I'm supposed to do? I'm supposed to be aware that there are double quotes on top of it. And then if you're a Mac user, it should be easy. If you're a Windows user, you are supposed to add a backslash to all of it. In all the places where you have one backslash. So basically add one more backslash to set the directory, right? So now go to your system and set your directory where you can access your files. The directory is set, and once that is set, I can use a command called list.files to see what is there, what kind of files are there in my directory. Now I'm able to find basketball CSV. That is what we are going to use in this session, and that is there, right? So I'll give you some time in order to set your directory and also to access your file. Let me know if you're once you're done, just type in yes in the conversation box. Okay, I'll have it here. And if you have any problems, feel free to ask me in setting up your directory as well as setting up, like, accessing the file. Hi, Naveen. You didn't miss anything. So basically, we are revising the last session. So what I revised is that how will you get to know about your directory? So you'll get to know about your directory by typing in a command called get wd. And then now you'll set up your directory to access the datasets. So what I told you is that to put the file, the basketball.csv file. No worries, Anirudhan, no problem. So I have uploaded a file here. You can download that file and then put that in the working directory to access it. So in order to see where the file is there, use this command list.files. And once you are already set with your working directory and you are able to access your files, or even before that, you can just type get wd to see what kind of directory you're in, to double check. So which is another possible way, right? Okay, right. So how is it progressing, guys? Like, are we doing good with this one? You're able to are you able to load your um, are you able to get into the right kind of directory that you wanted to go? Yep, perfect. And so which means like then we can, okay, yes, from Arun. I'll just wait for maybe Swati and then Naveen. Wonderful. So you are going even beyond that. Okay, perfect. Oh, you are adding your CSV file to the directory. No problem. So let's just wait. Okay. Okay, let me provide you a kind of revision again. Since in order to get to know your directory, you're supposed to ask the system get wd, and when you want to set up your directory, and you copy the path of the directory and add it in. For Windows users, please be aware that you are supposed to add a backslash on the top of the one backslash that is already there in the path. For Mac users, you don't have to worry much. Why? Because there is a single forward slash in your system. And then, no problem, sir. Thank you. And once you're able to get into your directory and check whether the directory is there set properly, and you can use the command again, get wd. And if you want to access the files, then use list.files command. Then that will show you what are the files that is available. Okay. So now, is everyone able to access the file, and are you able to go ahead? Okay, Swati said yes. Yeah. So now, Naveen,
So
you're
Bala,
able to access.
so
Yeah.
this is my directory.
Mm-hmm.
I'm getting with the command get wd.
Okay.
So now I have to place my CSV file inside documents. Is it?
Yeah, you can put, yeah, there are a couple of ways that you can do. One is that you can copy the file, download the file, and then put it in the documents folder
Mhm.
to access it, or rather you can put it in the place where you want,
For
and
that, I
then
have to set the path.
for set the path. Yeah. So like for the moment, if you're running short of time, maybe just put the file in the documents, then you can access it.
Okay, fine. Thanks.
Yeah. Yeah. And anyone else missing? Like if you're having any problems, like if you're facing any error, just let me know. Nothing at the moment, right? So shall we proceed? I assume that we will proceed further. Like if just interrupt me if I'm going a bit fast. Now, so since you are already in this directory and you're able to access the file, now you are supposed to create a variable or object basketball and then read the file. How do you read it? You use read.csv, and again, please be aware that you're supposed to use double quotes basketball.csv and then store that into basketball. Now, simultaneously in your system, work on this part. Now the basketball is the data file basketball is read, and then now it's stored in the directory, the object called as basketball. Now I want to know what kind of class that is. The class means it can be a data frame, it can be It can be a data frame, it can be a vector, it can be a matrix and other things, right? But I do not really know what kind of object that is. I want to know the class of the object basketball. And what I will do, what command can we use? Maybe open up your mic and just say, or like maybe type in the conversation box. What command should I use to check the class of the object?
str.
Yeah, either you can use str or you can use class, right? At the moment, I'm just using class basketball. Okay. And then it's a data frame. And if I want to know more about it, and then I'll use structure command. Okay. So basically, you can see the difference between those two commands. One is class, just gives me what kind of object it is, and structure gives me more information. It gives me even within the object basketball, and there are multiple columns, and the multiple columns have different kind of variables like vector, numerical variable, integer, and other things. Right? This is given to us. Okay, and now the other way to work on to find more information about the structure was like the basketball data set is to use a command called a summary. Hope we did not use it last time, so I'm planning to show it this time. And I'll explain you what does the summary function do as well. Okay, so once you executed that one, all right, you can see the summary basketball shows me all the columns that I have, and also it produces some sort of statistics out of it. Yeah, perfect, sure. And Swati, where do you want me to start again? Like, if you want me to
No, you don't have to restart. Ah, yeah, this is much better, and you don't have to restart, but just a bit slow.
Yeah, cool, I understand. Or do you guys want the R script file?
What?
Like the script file, do you want the script file?
Yeah, okay.
Maybe I can share it to you so that you don't have to type everything in your system. You can just open this file.
Okay.
Yeah.
Easier.
Let me see if I can. Okay. Okay. Did you guys get it? Okay. Not yet, right? So I don't know why. Okay. Okay, I think the file is not getting uploaded for some reasons in Skype. Okay, let's go with the flow. I'm really sorry. Perfect. Next time I'll ensure that I'll upload this R script file before the session. Okay, right. Okay. There is some error in my R. Let me restart it. Perfect. Right. So now let me go back again. I'll tell you how to do it. Like you have basketball .csv file, and I read it using read.csv command, and I stored into basketball variable, or it's like I call it as an object as well. And if I want to know what kind of object that is, especially whether it is a vector or a matrix or a data frame or a list, then I can use a command called as class. So I use class basketball. Yeah. So I use class basketball to see this, the structure of the data, and whether it's a data frame list or something. And then if I want to get to know more about the data, and I can use a command called structure. And later on, I'm also using a command called summary, right? Which is what I want to explain again. For that, let me run the command so that it is in my R environment. Okay, so now if you look at this summary part, the summary part explains me what are the columns that I have in my data set. I have training period, region, height, weight, field goal percentage, and free throw percentage, and average points. So these are the data that is available, the column that's available within the object basketball. Okay. And also we can observe multiple different outputs, which is called the statistics of this column. The training period has childhood, school, and university. They are factors, and it just provides me a count information. So there are from childhood people who get trained or like getting training is 24 people, and during the school days the number of people who got training is just 7 people. In the university is like 23 people. So when they went to the university, they got training. Right. And similarly, you can observe people who represent different regions within the data set. So there are 8 people from Africa and 12 people from India. And these two are just throwing me numbers. Why? Because that is a factor. Right? In case of height, weight, and other things, they are numeric. Hence, it will throw me a result which is called as minimum value in that particular column and the maximum value in that column. So this is called a summary statistics. These are basic descriptive statistics that is used by statisticians to get to know what kind of data it is, whether it is distributed, how it is distributed, and other things. Okay. In the first quartile is the first half of your data, and the first half, 25% of your data, where it stops at 6.25. Okay. And the median of your data, I hope if you're not aware of statistics, just let me know. But if you're already aware of statistics, I assume that you know it, and then I'm just going with the flow. So it produces a median value. So median value is a midpoint of the entire data set. And the mean value is the average value of the data set. It's like the column height, and it is 6.5. And the 75th percentile, I was like the 3/4 of your data point is at 6.90, right? And this gives me a basic idea about the column and then the basic statistics about that particular column. Okay, and which is useful for me to see how the data is looking like. For example, say the minimum height is 105, which will not be, it is not really suitable for a basketball player, right? He should be normally around 1.8 or something, but it happens only at 1.85. Hence this guy, or like this number might be kind of misleading the entire data set. Maybe we need to remove that later on, or else we maybe need to double check it in terms of maybe there is a typo when they entered into the data set, right? So apart from that, we have other data points, and we can also use that for calculation. But that is how you can extract information basically from any data. In terms of getting a basic descriptive statistics can be done with a command called a summary, right? And now I'm moving on to the part of kind of what's say in the sense of tidying up your R environment, right? You can see a lot of data points loaded here, right? But I don't really need all of these things. Okay, I need basketball for my analysis, but I don't need the Nutri-Score data and test data and test one data, right? And in case of tidying up, I think, let me put it on the top. You can use a command called as a remove function, which removes an object from your R environment, right? So here I can see basketball. I just need that one. Hence, I am going to remove Nutri-Score underscore tidy, which is already loaded in my system. So I'm just removing it. And if I want to remove more objects from the environment, I can just put a comma on the top of it and then add all the objects and then remove them. So what will happen now, once I execute the command, you can see these three things will go off and you will just have basketball in your environment. Yeah, do you see it? Right. Now I can really see only basketball there. Right. Sometimes it is not accessible by accessed by, you cannot really access it in your R environment. And if you want to really specifically know what kind of data set that you're working on, and you can attach it and detach it later on. So use it for some purpose, and then later on you can just detach it so that you don't use it for the other following commands. Okay. So how to do it? So you can say attach
One
basket.
second.
Yeah,
Um,
please.
about the remove, what is Nutri-Score tidy? I don't understand that part.
They are some of the data set that I used to analyze, right?
Okay.
But for the class, I don't need them,
Okay.
so
So
I'm just removing it
okay,
from my
but we
environment
don't have to do it, right? Because we don't
because you don't
have.
have anything.
Yes. Okay. That's why.
Uh,
Okay.
Maybe you can do this and then create an object like x is equal to c of 100 to like 1300 or something.
Okay. Now I.
And then you can also do, if you want to do it on your own, just try this one. Yeah. So if
Okay.
I, so this will get executed and it will create a vector from 1200 to 1300, and then you
Mm-hmm.
can remove the vector using remove x. Okay.
Okay. Okay. Thank you.
But don't do this because I think this is a large number, right? So you don't want to do it. So now you can see the x is added, right? The value x is added here.
Mm-hmm.
Yeah.
Okay.
But if I want to remove it, I can just remove it. So
Okay.
it's easy, right? So
Easy. Yes.
instead of having multiple data set into my system, the ones that I wanted, I can just retain them and
Mm-hmm.
then remove all the things that is not really required for the analysis. Yeah.
Okay.
And I'll also show you how this can be used in future so that you'll be able to understand it in a better way. Right? Let me answer one of the questions. Did Arun ask me a question? No. Okay. Looks like I got a message from you. So hope things are going well. And now, so I'm at the moment I have an object called as basketball. I'm just attaching it, right? And also there is another object called as empty cars. That's an object, that's a data set already in our system. But however, like if I want to, I'm just showing it here at the bottom of the console. See here where my mouse is. And if I type empty cars and if I type then if I press enter and I get the data set, right? But I cannot really access the objects within, I can also access the objects within the empty cars, right? Because it is loaded in the environment. Sometimes your data set might not be loaded in your environment and you want to attach it, and you can use a function called as attach basketball. This will attach the data set to the R environment, and later on, and if you know, whenever you want to remove it, as like detach it, and you can detach it. So from that point onwards, this object will not be executed. In a sense, it will not be understood by the R system. Okay, we say a basketball, and it is there, still loaded, and it's there. But in general, you can use attach and detach function. So to attach one object and detach one object from the R environment in terms of performing some actions. Right? However, like we don't normally use this part in terms of attaching, detaching, but this is also required when you are working with like more data set. For example, say you have like 5-6 objects and you do not really know which object that you are working on, and if you want to access only basketball at that point of time, and use attach function. And once you are done all the analysis basketball, then you can detach that basketball dataset from your codes. Then you can move on to other dataset that you want to attach it. Okay. And imagine there can be a case where you want to remove everything else, every single thing, right? Removing all the objects in the R environment. I don't want anything. Don't perform this in your system, or else like you lose your basketball data. Don't do it. So I'm just showing you how to remove everything. Then I will execute on my side, and then I'll show you uh, the other functions. Okay. Removing all the objects will be like you say rm, right? And you say list is equal to ls. Okay, so basically remove and detach is different. Okay, remove permanently removes the entire data set from your R environment. So attach is like you access the particular data set for calculating something. For example, I can say attach basketball, and then I can perform like summary basketball, and then if I want to discard that information from for further analysis, then I can detach it. So it will be there in our environment, but it is not completely used for the further commands. So you will detach it from executing in the following commands. Okay, so that's the only difference. But this is complete, like you permanently remove it. Here you don't permanently remove it, but you can like access it, and then you can stop accessing to the data file. Okay, so imagine that if I'm going to use this function, remove list is equal to ls. So the ls is like list of objects that is there in my environment, and I can specifically say what object I want to remove, or else I can just say if I give it blank, what happens is that it removes every single thing from my environment. Now you can see I have basketball here. That's the only object that I have. If I execute this function, and everything will go off, right? And imagine that I want to call basketball, I can print it, right? So if it is there in the environment, but now it says the object basketball is not found. Why it is saying? It is because every single thing in my R environment has been removed by this command. It's a pretty easy way to remove everything. Like if you have voluminous data, and if you want to just like stop everything, just shut it off, then you can remove it. However, the word of caution is that once you do it, everything goes off from the environment. Then if you want to access some data files, and then you need to do like what I'm doing now. So you need to go and then read the file and then use it. Now it is read, it is stored, then I can use it. Any questions here? Any questions here at the moment?
Can we reattach after removing this object? So can we reattach this thing with the attach command, or we have to go through again and run that object and then it will come up?
Once when you perform attaching and detaching, yeah, you can re-access it by attaching function. But if in case if you have used detach function, and what happens is that it detaches the object from your R environment, right? Let me see. Okay. So attach and detach, we normally use it for data frames. I'm not really sure whether that will work for a vector. Yeah. But that's a kind of like you access to some data set and then you detach it later on so that you don't have access to that again. But this is performed in a kind of like when you are kind of want to use it in a very nice way. In the sense you load some data sets and then you perform some functions within for that particular data set and you attach it, and then later on you remove that from the codes. What happens is that then for the next set of code, you can if you want to re-access it, you can attach it or detach it, or it's like it depends upon how you want to work with, right? But how like in my normal work environment, I don't really use this function, right? Or what I basically do, I normally use a remove function so that I create some subsets of data set and then I access it, and the subset will be removed later on so that I have a tidy environment here so that I don't have a lot of clutter of data created. Okay. Any other questions? Like Venkat, are you clear?
Yes.
Okay, cool. So now let's move on to the important part called as installing packages. Subsets. Okay, I told subsets of data. Right. Imagine I'll show you when I do the dplyr command. Okay. So in the dplyr commands, we'll create subset of data, and then we can remove those subsets of data because we don't really need that for any other stuff. Okay. Let me show you in the later part. Okay. Right. So next, let's move on to an important part called as installing packages. Why? Because I told you earlier we have somewhere around 10,000 packages in R. and we don't want to use all of them, but however, like we'll need very few packages. And if you want to install those packages, and you need to use a command called as install.packages, and the package name has to be given within double quotes. And say, imagine we are going to load dplyr for this session, and it's already there in my system. Hence, I want you to install the package in your system. This may take a while. And if you have any problems in installing the package, just let me know. Like, try this command, install.packages, and use dplyr. I hope you have like very good internet connection, and if in case if it is there, then it should get may take like 2-3 minutes to get it done. So once you are able to install a package, install dplyr package, and then just let me know. Just type yes in the conversation box. Done. Okay, cool. That's quick. Perfect. Perfect. I think then, yeah. Yes, Naveen, it's done. Okay, fine. So there now we can see. Let me explain why this is happening, right? So you get like kind of. Let me show this one. So what happens is that on the top, like some of the packages have some dependent packages, okay, and they will normally get installed automatically without your command, right? And if you want to say that if dplyr has some dependency packages, and you also you want to install that one as well, and you say dependencies is equal to true. So whatever package that is depending on dplyr will also get installed. Right. So at the moment we are not using this command. However, there are some base packages that is required to run dplyr package. Hence, those things that is required to install, like to run dplyr package, got installed as well. Right. So now let's call in the package. Right. Now you have installed the package. However, it is not really called into the R environment for performing any like any activity using the package. But if you want to do that, and you're supposed to use a command called as library dplyr. Right. So once you execute it, and then you can see a message at the bottom saying attaching dplyr. And this message will come mostly for dplyr package, and for some of the other packages you will not get. For example, say I have many other packages which I use. Library mass. Right, and this is also showing a message. Tidyverse, I have tidyverse, tidyr. So in the information that you get from attaching, like calling in different packages, will have different kind of information. Okay, so here it also shows me some conflicts. Okay, we'll talk about conflicts and then how to handle conflicts later on. But for this session, we'll just understand how to install a package and how to call the package into your environment. And the information that it shows is not really required. However, like maybe you can understand it. a bit like, okay, it loads dependent packages, or it's like it loads the packages within the package will also get loaded. Okay, so I hope you understood how to call a package into our environment, right? So the functions within this package will get executed only when you call in the package using this command, right? Okay. Now let's stop it here in terms of like packages calling. Let's move on to combining columns, and later on we'll use dplyr package for other aspects. Okay, yeah. So this should be the message that you should get. Yeah, we'll talk about is like the objects are masked from package stats. Okay, and what does it mean? The filter command and lag command is also existing in the base package called stats. And what happened is that the dplyr package, when it got loaded, it masked those commands. Only the commands from dplyr package will get executed now. Yeah, and similarly for the other base package. So these functions are also available in base package. And what happened is that by attaching dplyr package, the commands within dplyr will get executed, but not from the base package. Okay. Okay, now let's move on. I told about like adding, creating a data frame in the last class, where we have two objects and then we can add that as a data frame, right? However, if I want to add one more column to an object, I can also do in a different way. So I have created two vectors, range from 1 to 10 and 21 to 30. Then if I want to add it in the column ways, right? So I take the columns and then you can use a command called as cbind, that is column bind. Okay, let's see how it works. X and Y, and I type and execute Z as well, and I print Z, and now you can see in the console those two vectors got added in the column fashion. Okay, let's see the class of Z. It'll get executed. Let's wait for a while. And before it gets executed, let me move on to the next part, where you add the data row wise. Okay, so now the class is called as matrix. Like when we did it last time, where we used a command called as data frame of X and Y. So which means it will create a data frame called Z. But in this case, what happened is that we just added them together, and it's like we combined in the column fashion X and Y. So now it is assumed as a matrix, not as a data frame. What can I do if I want to make this as a data frame? If I want to make this matrix as a data frame, I can call a command called as.data.frame and Z. Right. Okay, let's mute him. Perfect. Right. So now what I'm trying to do is like initially the object Z is called as a matrix. However, I just now want to call that as a data frame rather than a matrix, right? And this is called as coercing. Okay. So what could have happened? I feel like, let's see, this code executed already. So if I say the class of Z, now the same matrix has been converted into a data frame. You can also print and see there is no change in your data structure. However, you can see the matrix is converted into data frame. Okay. And you can also reverse it. In a sense, imagine that you want to call this as a matrix again, and say as.matrix for C. So this is generally called as coercing, and coercing is normally used in many cases where if you want to convert that from a numeric to integer, and you can say as.numeric, and you need to understand the structure of the data. Okay, so don't call as.numeric on z, okay, which is already there as a numeric, so there's no purpose into it. Right? You have commands like as.integer, right, and as.numeric. Similarly, you can have as.factor and stuff like that. Okay, so this is how you can coerce a data. Any questions here? You can also say as.list. Any questions here? At the moment, do you understand coercing? Page did not load for you. Okay, so like which part of your page? It's like, is it the script file not loading? My screen. Okay. Do you want me to explain again, Swati? Okay, done. Right. All right. Good. Right. So I hope you understand coercing. Right. So let's move on to the part called as combining row. Okay. How like I'll move this section and then for the later part. So let's work on the same. Let's work on the same two objects. Like we created X and we created Y, right? And now try to do R bind. Like you bind them by rows. Okay, and try to do that in your system and see the output. So once you get the output, just put it in the conversation box. Let's see whether you are able to get it right. And assign that to an object called test. Okay. Okay, let's see. Arun has sent a message. Okay, so when you do R bind, you can see those two vectors are arranged in a row fashion, right? When you do a C bind, it is arranged in a column fashion. Okay, so this is the base for your, like if you have like multiple data frames and you want to add them together, and then you can do it. Imagine you have basketball data set and then you have another data set which is having the same kind of column and other things. Then you can both basically combine them together using C bind function. But that'll I'll also cover that in the later part of the class as well. Not today, maybe in the next upcoming weeks. We'll talk about how to combine or join two different data set. Okay. Now, so once you, I hope you're clear with C bind function or you're clear with R bind function, and also you understand the coercing part of R. And now let's move on to plotting function. These are some basic plotting that you can do with base R, but I'll also cover extensively about ggplot2 in the upcoming sessions. Okay, we'll talk about a package called as ggplot2, which is far more comfortable, and it requires a lot of coding compared to base R. However, you can customize your graph in whatever way that you want to do it, and they are really aesthetically beautiful, and then they are good to look at. Imagine if I do this plot command on empty cars is a data set that is already attached. Okay, but you can also do that with basketball. Let's say basketball. If I plot without any sort of information, okay, I'm not telling R that you do this or you do that. You plot an Instagram, you plot a box plot or you plot a bar chart or something. I'm not saying anything, right? I'm just telling plot basketball. Right? So if your screens are in this fashion, and yeah, sometimes you might get a image, and if your screen is not fitting, if your figure like the preview box, if this is too short, for example, say this is too short, and it says the margins are too large here, right? And imagine that if I'm going to execute that again. Now you can see there is a error coming in. It says the figure margins are too large because the preview pane here is not able to plot that large. It's like the plot that is created is too large, but this pane is not able to show the preview. Okay, so you need to expand it. So this is very basic error in R Studio. Hence, if you just expand the pane and then execute that again, and that it will show, right? This is not an error from the code, but the error from the R Studio. Okay, so please be aware of that particular error. Now let's see the plot. So now you can see the column names are given here: training period, region, height, weight, and field goal percentage, and free throw percentage, and average points. So these are the column names, and this is actually called as a correlation matrix. Okay, it's a cross correlation matrix graph. However, like we also have some factors within that cross correlation matrix, right? And you can easily identify those factors using this, using the graph that has been produced. Okay, here you can see they are plotted in one single line. Okay, this is one factor, this is another factor, and similarly you can see the results for training period on height and training period on weight and other things. And this is listed here, and we'll not really explore into how these things are working and how this data can be interpreted, but we'll do those things in the future classes. Okay, but you can understand just by running a command called plot, R can easily understand the data, and it can produce a graph which is suitable for the data set. Okay, so you don't have to worry much sometimes. And let's see if I want to plot histogram. I hope you're all aware of histogram. Anyone want to get an explanation of histograms? Or are you comfortable with that? Yes, okay. So whenever a data is there, the data is normally assumed that is normally distributed, since the distribution of the data is normal or not. And so in order to understand whether the data is normally distributed, and you are supposed to plot a histogram. Okay, and that is normally happens when you are running a thesis. If you are writing a thesis, if you're a research student, or else like even if you're a data scientist, and they normally look for the distributions. And the normal distribution curve is a kind of a very it's a kind of a bell-shaped curve. Okay, let me show you normal distribution so that you can understand that. So what is the assumption behind this normal distribution curve? So the assumption is that the normal distribution curve, okay, let's go here. So whenever you are having a data, and it is assumed that the data has more than 30 points, right? Imagine you have collected a lot of data, and the observations, like number of rows of the participants, are really more than 30. And in that case, you will have the theory says, or the central limit theorem says, your data will go on a normal distribution, where your data will have a bell-shaped curve. It will assume a bell-shaped curve. This is an assumption, right? But not all the data will go with this assumption. And hence what we do is, like, we want to check whether data is normally distributed or not. In the normal distribution, and the basic tenets behind normal distribution and data science is a very different story, which we are not really worried much today. But I'll just show you this is a normal distribution curve, but we do not really know whether it is normally distributed or not. And in order to see that, and we will plot a histogram. Okay, let's say basketball weight. Okay, so let's see whether it is normally distributed or not. Also, like we can easily observe. Okay, so there are people who move from 100, 150, 200, and 250, and we can see a lot of people in the 200 pounds category. Okay, and this is a histogram. And similarly, you can see a box plot for the basketball. And box plot is also similar to the ones like histogram, but box plot has a capacity to show outliers. If there's a very different since if there is a, what do you mean by outlier? Imagine that you are traveling in a bus. This is a normal example shared by many statisticians, right? If you imagine you are traveling in a bus, and if you calculate the average income of people in the bus, it should be some, imagine from the situation from India, it should be somewhere around 23,000 to 40,000 or 50,000, right? And now I'm going to put Mukesh Ambani into the bus, right? And what happens is that everyone's average salary will jump from 23,000 or like 22,000 to like 2 lakhs per month. Why? Because of Mukesh Ambani's presence, right? So Mukesh Ambani is now considered as as an outlier. Okay, so I don't want Mukesh Ambani to be there. Hence, I can plot a box plot and see whether 25 crores per month if you add Mukesh Ambani. Yeah, might be, yeah. Right. And you can see a box plot created here. And now you can see there's a small dot. I think it should be very good in your system. I don't know why this preview. Okay. Let's see. Yeah, now it's coming really well. Now imagine that I have a data set now, and since I plotted a box plot, in the box plot, what you can see, this is the minimum point of your data set and the maximum point of your data set. And this dot is an outlier. The dot over here is an outlier. And this is the minimum point. However, like even this is the minimum point, but this is considered as an outlier. Okay. And then the dark bar, like dark line within the box is called as a median line. So this is a median point of the data set. And then this is the first quartile. That's when we discuss about summary, and we talked first quartile, like first 25% of the data. So the first 25% of the data is from 150 to roughly around 175, and then it starts to the next 50, and this is the next 25%. This is the 75th percent, and this is the next 25% of the data. Okay, but when you look at the histogram here, it generally follows a kind of a normal distribution curve, but it is skewed to the left. So we'll talk about these things. These are like basic statistics, which is not really required for this session. But in the sense, you should understand, okay, about normal distribution and other things. So we can have a session later on. If you want to get into data science, you must learn statistics, okay? But we'll keep that scope for the future classes, right? So if you draw a kind of a curve, right? Look at my mouse, okay? If I'm drawing a line like this, and then it is quite similarly follows a bell curve, but the bell curve is shifted to the data points are shifted to the right end of my spectrum. Okay, hence this is called as a kind of left skewed curve, since there's a flat tail on the left hand side. And if you're not from stat background, this might be daunting. So don't really worry about it now, but the basic idea is to show you that the R has a capacity to plot data. Any questions here? Any questions here, guys? Nope. Okay, cool. Thanks for your feedback on it. And then let me proceed. And we are getting to the interesting part of our session today, and we are going to use dplyr, right? And the dplyr has is kind of very has a versatile capacity in terms of subsetting data and then organizing data in a very beautiful way. Okay, so I think your dplyr package is already loaded in the environment. If in case if it is not there and you say library dplyr, you can call it many times. I'm just say might not, may not be. Check the recordings. So I can now call in the package. Okay, as it's already loaded. So the first verb, so there are 6 basic verbs in dplyr, right? And if you want to know the dplyr verbs, you can say dplyr cheat sheet. There's a PDF available which talks about how you can use dplyr package to wrangle data, in sense to manipulate data, or it's like wrangle in the sense you play with the data basically, right? And this is available as an open PDF file, so anyone can access it. And just putting the link here so that you can refer to this one in future. Okay, so the basic verbs are select, filter, mutate, and arrange, summarize, and group by. So these are the commands that is available. So we'll just talk about these 6 things today. So what is select? So select basically helps you to select columns of a data frame. So I have a data frame called basketball. So imagine I'm going to say I want to just select only weight and height variables from the dataset basketball. Then I can use a dplyr pipes. Okay. So I'm creating so I would recommend you to follow this coding in your system as well, and just type in whatever I'm typing. I'll explain the code a bit later. Okay. So how do I begin, and how can I begin with dplyr pipes? And it's basically you start with the data set name. So that is basketball. Okay. And I used a percentage sign and a greater than sign, and then a percentage sign. In this structure is called as pipes. Okay, I can just put it as a comment here. This is called as pipe. Okay, and this pipe structure is used so that you can layer by layer you can add a lot of pipes, and these pipes will allow you to subset the data in the way that you want to happen, right? At the moment, what we are trying to do, we are trying to select only few columns from basketball. Okay, so if I want to know the call names, basketball. Okay, the column names are training period, region, height, weight, and field goal. I just want to say select height and weight. Okay, hence I can say height, weight. Okay, and also remember that what I'm doing here is that I'm typing as such. So it is case sensitive, R is case sensitive. So whatever is however it is shown here is the way that I'm typing in here as well. So the dplyr command now understands. So it uses the data set called basketball, and then it just the user just wants to select only the height and weight column. Okay, let's execute this command and see what happens. Okay. Let me see, there's some error. Okay, let's say basketball Okay, so okay, the problem now is if I'm just selecting one column. Yeah. So what happened? What's the error that I get is because I am having two columns, right? So I need to say combine. So I missed that one. So it does not. I'm getting the same error again, but it should not happen like that. Yeah, it should work, but it should normally work without the C, and it should get executed, but it's not getting executed in my system. Maybe it is having error in multiple packages. So as I told you like when you have multiple packages, right? And then you will normally encounter error called as conflicting, right? And then you need to specifically say which package to use for this one. Yeah. Why it worked for you guys is because it worked for you because you just have only dplyr package. However, in my case, I have select like I have different packages in my system, and select is also there in some other packages. Okay, especially from tidyos, I hope. Hence, is it not working for you? Okay, so which means like try this one, try this the pattern that I typed here, and that should work. Okay, can you just show me a screenshot? Or like maybe share your screen and then I can just look into your error. Yep, please. For others, like if you're already done, right? Let me give you another task, right? The task is to select variable training period,
Small h.
region, and average points. Yeah. I typed in a fashion that it's typed as an instruction, but you need to select using the column names. Okay, try this one and tell me, and assign that to test one. Call that as test one. Okay. Right, Arun, can you just open up your mic and tell me why it's not working?
I think this is h is small. It should be.
Yeah, that's what like show me the codes or like show me the screen so that I can solve your problem.
Whose screen is this?
This worked okay, but is it not working with the height as well? It should work. Give it a try again. And check whether you have used the proper like since R is case sensitive, and ensure that you use the kind of a similar column name. Yeah, try to use both of them, select both of them as well, and then do it. And Swati, are you able to solve it? Could not see your screen. Maybe take a screenshot. Like, maybe should I stop sharing my screen then? Good here. Okay. Swati, like. Okay, I can see your screen now, I hope. Yeah, okay. Right, so initially you had the problem. Why? Because the height has capital H in front of it. But now it should get worked, like it should work. Why? Because see, when you're typing in the variable name, I was like the column name, ensure that it is in the exact fashion how it is stored in the data set. Okay. Now let me share my screen. Okay. So if you want to know what kind of column names are there, right? So I normally use call names of basketball. Okay. So this will just produce me the names of the column, so that I don't really get into any trouble, so that I type the exact names as it is in the data frame. So this is already executed, you can see here. Yeah, perfect. So do the task, please, and then also complete and put in an S later on. And also print, test, and see how it is looking like, right? So that is also important. So for me, the test and test just has height and weight, so I'm just having it here. So for you, you will select training period, region, and average points, and then assign that to test one. So basically, test one, say basketball. I'll leave it to you now. So you can continuously write like this, or you can also press an enter and then go to second line and write it. It will also work. Okay, and select. Okay, let's see from Anirudh. Okay, so that's how you perform, right? So you selected height, weight, training period, region, and average points. Perfect. But the task is to select training period, region, and average points. If I'm right, so you must have training period, region, and average points. Okay. No problem. No problem. I hope you understand how things are working, right? So that's enough at the moment, right? So good. It's also really nice to see Venkat using head part, and so that you don't load all the data set and you're using something that is learned in the last class. I appreciate you, Venkat. Right. So test one. Now you can see that we created two different subsets of data, which has test has only height and weight, and the test one has training period, region, and average points. But in future, you may not really use them, right? So that's why I use remove command, so that I just remove all the variables that I create, like a small. Um, I normally create small subsets of data and just remove those small subsets of data, so that I'm not confused anymore. Okay. Now, right. So what I'll do is basically I just remove them, test and test one. What happens is that my environment is now clean. Okay. So I'll also say.
Well, wait, what is the head thing?
Okay. When you so head, if you want to see the first 6 observations, right, of the data, to get an idea how the data is looking like, and you can use head, right? And the next command is called tail, and that will show you the last 6 observations of your data.
Okay.
Shows the last 6 observations. Clear? Now I can also remove XYZ. I just did it, but if I do it now, and it will not execute. Why? Because it's already it's already the objects are removed, and so that will produce an error. So now you can see my environment is clean now. Though I have created a subset of data, I just looked at it. Then now I just removed it so that I have a very tidy environment. Okay. Hope you understand select. The select will also work in a very different fashion, right? You can also use numerical numbers to do the task as well. Okay, so task select variable and pick only the first 3 columns. How can I do that? Imagine I'm going to say test again. In basketball, select. Okay, maybe I need to use dplyr select. And then I say 1:3. So this will pick the first 3 columns of basketball. And similarly, whatever you did in your subsetting function, right? You did some subsetting last week where you said like we can also do some negative subsetting in sense remove only 6th column, like we say -6. And you can do the same thing here. Okay, if you just see head of test, and this is just first 3 columns. Okay, imagine I'm going to remove the first column and present it, and I can do with a similar index subsetting. Now you can see the first column is removed. Okay, and you can also see the same difference here where basketball has 54 observation in the environment pane and 7 variables, but the test has only 6 because I just removed 1. Right, and similarly I can also do a combination. Right, I can say 1, but you should know the index properly. If I just give 8, it will not work because it has only 7 columns. If I say only select 1 and 4, it should also work. Okay, so what happens is that it picks only the first column and then the 4th column, and it puts in front of me. Any questions here, guys? Okay, I assume that you understand how the subsetting, like maybe subsetting or select command in dplyr works. Okay, let's move on to filter. So filter is used for selecting rows. Like I will just say put it as rows, used for rows. Okay, but select command is used for column. Okay, it's used for row values basically. Let's have a look at like imagine I put another test 1. Again I say basketball and filter. Let's use dplyr filter. Maybe it might work. I assume that it's going to conflict with some other packages I'm using it, but if in case if you don't have much packages, you can just type filter. That should also work, right? And filter of so I have this data set in front of me, right? I want to know people who are equal to or like more than 6 feet. Okay, then I can use the command called as filter, so which will pick the values within the row. However, it filters all the data above 6 and then gives me the entire data set. Okay, let's look at how it is not looking like. Height is more than 6.0. Okay, and say head test 1. So what you are basically trying to do here is like the filter function, you are filtering based on the row values, and then you're just selecting. It's quite similar to the Excel filter function, and thus the name is also coming from that Excel command. And now if you look at, and now this will have only the row values of height more than 6, but it also shows me the entire data frame. Okay, this is not I'm just filtering based on the values of my required condition. I'll give you an example from my research perspective, where when we do research, we collect data from participants online. What participants normally do is that they fill in the data, the survey in like 30 seconds or 40 seconds. But when they fill in the entire survey in 30 seconds, which means they have not read any of the information that is in the survey, they'll basically go on, click, 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 and then they'll submit the button and then go, which means they never understood the survey. So we just want to filter them out. So what we normally do, I'll say, okay, so basketball, imagine basketball has the same stuff like duration and say we'll select only people more than 30 seconds. Okay, it omits all the data, the observations, which who have not really read the survey. Yeah, and it's easy for me to filter. What I'm planning to do for the task is that use select command and then filter. Okay, so how can you do it? I'll just do it kind of a demo first. Like you say test 2 basketball, and you use select first with something, and again if you want to add on to the top of it, and you can use another pipe, and then you say filter. So what happens in the first case is that you select some columns and then you filter based on the row values. Okay, and let me show you, let me give you the task, right? In the sense, select training period. Yeah, I'll tell you why, Anirudh. Give me a second. Select training period and field goal percentage. I was like maybe just have it like average points, because you'll have to type a lot for those two columns. Okay, and then if average point more than 0.5, that's like 23. Okay. So it's the average point that the player scored in a match. Okay, so we want to see the player who played more than like each and every game he scores around 23 points. So probably a MVP, like maybe I cannot really say any name, like Jordan or any other basketball player, if you're a fan of them. Okay, now let's back to the question. Get back to the question of Anirudhan. Yes, this can be skipped. So the case is that I use dplyr double colon. Why? Because I have another package which has the same function, and what happens is it overlaps with that package. Yeah, and that's why I'm using dplyr double colon. But you can also skip that one because you have only one package installed in your R. Good. Yeah. Amazing. Perfect. So if you look at Naveen's code here, what he has done is like he typed basketball and then he used dplyr select. He selected only training period and average points, and then he filtered average points more than 23. Right. I hope everyone is getting the same kind of output. If you want me to wait for some time, then I'll wait. Then we'll move to the next verb. Yeah, okay, I'll just wait. Okay, I'll just wait for like 5 minutes, like not 5 minutes, like 2-3 minutes, and I'll fill this code here. Okay, let me do one thing. Okay, from now on it should work. Let's see. Okay, good. Perfect. Okay, so I assume that everyone has done, and then now I'll move on to the next part called as mutate function, right? And you can easily understand that this will also work for in the case like it can also work for characters. Okay, so I'll give you another task in the sense use filter command to perform the same. Okay, so select training period and average points, right? But I need, for example, say basketball. I need only people from the university levels. Okay. Need data from university levels. So this is again a select and filter command, and however, like you are going to use a character for filtering. You get it? Right. So let me show you one, so that you can also you can understand how to subset using characters. And, let's copy this one. Filter. So now I need to say what is what, right? So I select training period equals. So you can see I am using double equals. Yeah. And that is important because whenever you're typing in something in the filter command, even if it is numerical value, if it is equals, and it should be double equals. If it is greater than, less than, it should be like only one symbol, so like just greater than or less than. However, like when it's equal to, and you're supposed to give equal to. And when you are using a subset for character, you need to be very careful that you are put it in the double quotes, so it understands that it's a character that you are trying to filter. Okay, and try this one in your system and see whether you're able to access, get the data. So you'll be basically getting only the data from the university levels. Right. Got it? Perfect.
How can we add two filters if you want to add?
Let's say if I want to say and average points more than imagine 10. Okay, so I'm adding two filters now. Yeah, and then you get it.
So the
So
same thing we
basically,
can add and or.
yeah. So for R, I think you should use this one, this or this. Yeah. And for and, you use this one. Right. So what are the other cases where you can get it, right?
Okay.
And or not. So this is the next part, right? So if you don't want something, okay, how can you dictate that in R? So if I don't want I want a data set except the university, then I say and not. Okay, and select training period's average points and filter the training period from where I just don't want to see university. Okay, so say now it's just picking only school and childhood. Okay, this is how you say the not command within R. Yeah, I hope this is clear now.
Yeah.
Perfect. So let's move on to the next part. And with this one, we will complete this session today. And the next week, we'll talk about the arrange, summarize, and group by function. Okay. Right. Imagine what we discussed earlier is that we just discussed on selecting some columns and then also filtering some values based on the row using filter command. Now imagine that I want to create another column. That's a challenge, right? So in a sense, you want to use two data points and then you want to combine them and then produce a new column. And I then use a command called as mutate. So let's say test for basketball. So now I just select height and weight. And then mutate. So the mutate command will basically give me, it'll help me to attach one more column or basically one more column to your data set, right? So imagine the height is in feet and I want to convert that into centimeters, right? So I also formula height in CMS. And where you cannot really give any space, if you want any space, if you feel that you want to add space, instead of space you can use underscore. Okay, and you need to specifically say the column name first and then followed by what you want to execute. Okay, and just say I want to just it should be like 30 centimeters up. Yeah, so if I just multiply that the inches, like the feet by 30, I think I should get in centimeters if my math is right. Okay, so don't worry about that, but we are trying to get height in centimeters now. But what about the weight? Weight is in pounds. Let's not worry about it, but just learn how to do it now in terms of height. Okay, so if you now look at test 4, what will happen is test 4 will have 3 variables. Why? But we select only 2, but we produce another column called as height in centimeters, and where you say height is multiplied by 30, so that it gives me the values in centimeters. Okay, and let's wait for the output. Or it's like you can just execute in your system. It should be faster, I hope. Yeah, now you can see the height column is here, the weight column is here, and height in centimeters is also there. Yeah, I'll add one more clause to it. Imagine I produced a new column, but I want this new column to be in the front end. Like I want that as a first column, and I want the weight column as the third column and height column as the height as a second column. So what I can do, I can add one more pipe. Select. Okay, the select command works in a very different way. So when you select something, it will also organize in similar fashion. Okay, now say height underscore in centimeters. Want weight to be in the second column, right? Height and height. Okay, so I'm just telling to produce a data set where the height is in the first column, height in centimeters in the first column, weight in the second column, and the height in the third column. Okay, and also just basically extract the entire data from basketball. Okay, and then it selects and does the mutate function, and later on it also performs another select function and then does it. Now if you look at the head test, now you can see height in centimeters in the first column, weight is in the second column, and height is in the third column. So that's the beauty of our dplyr package. Any questions here? Okay, so let me give you yeah, so that's another beauty, Arun. In a sense, it will not change anything in basketball. However, like if you want to add this column to basketball, so you assign the same to, so what happens is that the basketball data set is already there, and you are not doing anything in the main data file, and you are creating subsets of data file. Yeah, that's also possible. Just either I would normally the dplyr package is working in such a way that it does not really manipulate much in your main file. Okay, so if you want to manipulate in your main file, it's basically reassigning the name of it. So you can say basketball here, and then it reassigns it. Oh, but be careful here. So when you're just trying to reassign the value, and it selects only this and then adds it. Okay, or I can do in the other way. So for example, say test4. Okay, yeah. So now I can extract test4. Yeah. Okay. I'm trying to address the question from Anirudhan. Okay, so it is like directly mutating in basketball file. Okay. For that purpose, I am not selecting anything. One first clause. It's like I can select also. I can do that, right? But let's keep it like that. Then let's say test4, right? So basketball. You need to give the new column name, right? Height in centimeters, right? So now understand what I'm trying to do. I'm trying to assign the values from test4 to basketball. Okay. So initially I need to define the data frame where I want to manipulate. So I'm defining basketball first, and then I'm adding the new column name, which is not similar to the name that I gave for test4, and I'm adding it here. Then I am trying to assign that value to I'm trying to assign the value from test4. So test4, I have the data frame called height in centimeters. Okay. So now if we go back to head basketball, now you can also find the new column added here. So whatever you computed from that subset column is added here. Did I answer your question, Anirudh? Yeah. You can also use bind function, Arun. That's also possible. So it's not a problem. So you can also use bind function. What I normally do, you can, instead of this, you can also say cbind basketball, right, comma, test4 and height in centimeters. We cannot do rbind because rbind is not really so when you do cbind, then you can see the test4 height in centimeters is added here. It's like maybe let's say let's do that with the head command. So now you can see in the same I manipulated things and then added into the main data file basketball, where I can now find a new column added to it. It's test4 height in centimeters. Yeah. But how like are you clear now? You getting it, Arun? Do you get how to use okay, right? Any other questions for the day, guys? Like,
so I have one more question.
yeah, please.
When we do install packages and install a package in a script, let's say I have a script called test.r. Does it install the package only for the specific script, or does it install on a global scale, or global scope, I mean?
So if you install any packages, that will go to the R environment, it will not be only for the script.
Okay.
Okay. So whatever you do in terms of installing packages and calling in packages, that works for the entire environment and for the session.
All right. Okay.
So installing packages work for the entire software. It manipulates, it changes this entire library of your software. Okay. So whatever package that you installed will be there as a repository. And whenever you call in library, the library function works only for the session. If I close this session today, like if I close this file now, the library will not be saved. The libraries that I called in, like whatever package that I called in will not be saved. Okay, so whenever you are loading, whenever you're trying to do something in the next week, right? You should also call library dplyr again, so that the package will come into the environment for execution.
Okay, in that case, my next question is it possible to install script-specific packages? So let's say I have a specific project, and then for this project, I need some set of packages. So I don't want this packages to mix with my global scope of packages. Is it possible?
So you can install n number of packages within R, so it's not a problem.
Yeah.
But the problem is like when it conflicts within your with other packages. For example, say I loaded tidy words and then dplyr package today, and what happened is that I was not able to use select mutate function in a very good way, right? I need to type dplyr, right? So there is a package called as conflicted. So when you load conflicted package, what happens is it will says what package is mixing up with, or like having inconvenience with the other package, what are the commands that is overlapping.
Okay.
And then you can basically overwrite what to prefer, right? Let me show you library conflicted. That's another package. This is actually developed by the people who developed this package as well, right? And there is a command called as conflict prefer, right? And I can specifically say filter and prefer from dplyr package. When I say that, the system will say the existing preference of filter command is removed, and from now on, the dplyr filter will be preferred over the other packages. Hence, whenever you execute filter command, henceforth, it will only use the filter command from dplyr package. It will prefer from even if it is there, if the filter command is existing in other packages, that will not be used for this set of code, like from now on, basically.
Understood. Thank you.
Like, imagine that you want to use the other command now. For example, say you want to use a command from plyr package, right? Then you need to specifically say plyr with the double colon and the command filter. Okay, and that's how you can say declare, okay, from which package you want this command to be executed. Okay,
Understood.
all right. Any other question, guys? Okay, so if you don't have any questions, then let's sign off for this week. Let's listen. Maybe next week we'll talk about arrange, summarize, and then group by function. They are really useful as well. Okay, thanks, Swati. I'll see you next week in the same time.
Yeah, thank you.
Okay, thank you very much. I'll see you. Thank you, Manikandan.
Yep. Right. Bye.
Bye-bye. Please now be safe, stay home, have a nice weekend, guys. Enjoy.